Welcome back to the channel, guys. Let's continue our Lover Buddy essay sheet, the 450 questions cracker sheet. The question today is find largest sum contiguous subarray. It is also marked as very important. Okay. So the question says, given an array ARR of n integers, find the contiguous subarray containing at least one number which has a maximum sum and return its sum. Okay. So the question says we have been provided with an array ARR whose size is n. This is our input, and the expected output is maximum sum of a contiguous subarray. Let's understand what is the meaning of contiguous and subarray. Okay, subarray is simply part of an array, and contiguous here says continuous. Like if you have an array 1 2 3 4 5 6, so you have to pick a subarray like this only, like in a continuous term 1 2 3. You cannot pick like 1 2 then jump to 5 and 6 leaving 3 and 4 behind. You cannot take parts. Okay, you have to take the continuous subarray like a small unit from it. All right, so we have to return the maximum sum. Let's look at the brute force approach to it. The brute force approach. I am saying if you focus here, it says that it has to contain at least one number. So because it is saying that at least one number, I am saying initialize an answer variable as the first element of the array. I hope that is fine. Okay. Answer element is as the first element of the. Okay. Now I'm saying that run a loop for the first from first element of the array going up till last element, including the last element. Okay. And now for each time declare a variable curve which would be equal to 0. It would be starting from the 0, and use a concept of nested loop which will work from element I and go up till the last of the array. All right, everything simple from here. And every time curve would be equals to ARR of j, answer would be equals to maximum of the existing answer and the updated curve. Okay, and after both the loop ends, just return the answer. So in this case, what are you doing? You are taking all the subarrays, like the brute force approach is saying. What have you done? You have done like this. You're starting from here. You first computed the sum for this, then this, then this, then this, then this, then this, then this, up till this. After that, you started from here, then this, after that, this, then this array, then this, up till here. At last, the last array would contain only this element. So in this case, you have executed all the subarrays. Okay, all the subarrays of every length, and we have because of this statement, you have taken the maximum of the existing answer and the subarray sum. Okay, maximum is stored in answer. I think that is fine with you. The time complexity for this would be, yes, you're correct, O of n square. For those of you who do not understand why this is coming, let me explain. The first loop was starting from 0 and going up till n minus 1. Second loop was starting from I and going to n minus 1. So if we expand it, we see the second loop in the first time was going from 0 to n minus 1. In the first time, it was in the second time it is going 0 1 to n minus 1, then 2 to n minus 1, up till n minus 1 to n minus 1. So in this case, there were n computations, in this case n minus 1 computations, in this case n minus 2 computations, up till 0 computations. So for time complexity, we are adding all those computations. It would come like something like 0 plus 1 plus 2 up till n minus 1 plus n, which could be represented as sigma I is going from 0 and up till n, which is equal to n into n plus 1 by 2. Now, for every mathematician, n plus n plus 1 by 2 gives n square by 2 plus n by 2, and big of terms uses the highest power of n, it would be n square by 2, and removing the constant we got the O of n square. I hope that is clear. Moving to the space complexity of the above program, it is of 1 because we have not used any type of array or any type of data structure to store the elements or store the answer. We are just using simple variables, that is a constant space, so O of 1 is the space complexity. So you say that it is an efficient algorithm, but I say we can do the algorithm more finely. How? Let's move to the optimized approach. Approach to the optimized approach. All right. So optimized approach say that I will do it in O of n. Also, I will not use any extra space. I say how. How can you do it? It says that you do not have to do anything. Just declare two variables, sum and answer. Okay, I say okay, no problem. It says give answer the first element. I say why? It says because you have to include at least one element in your answer. I say fine, no problem. I will do that. Okay. Now it says initialize sum as 0. I say okay. I think because that cur is 0, so it says yes. Because you use cur as 0, initialize sum with 0. I say okay, no problem. It says now initialize a loop from I equals to 0 up till n minus 1. Okay, moving forward. It says for every step you have to execute three statements. First statement is sum plus equals to array at that index, array element at that index. I say okay. It says then update your answer according to the maximum present. Okay, I say okay, no problem. I will do that. Now it says if sum has gone less than 0, that is if sum is negative, convert sum into 0. I say okay, let me think. Okay, that is also fine by me. And it last says return answer. I say what? Return answer, why? Because answer will store our desired output. I challenged him, show me. So it says, look at the example given in the question itself. The question it says is 1, 2, 3 minus 2 and 5. Okay, I see. 1, 2, 3 minus 2 and 5. Okay. It says compute the answers given to me. Okay, I just write it down this 1, 0, 1, 2, 3, 4. These are the analysis. And the steps I have to do is in the initially sum was 0 and answer is 1. Okay. It says for 0, I will work for 0, then for 1, then for 2, then for 3, and at last for 4. It says every time we have to execute three step. Sum plus equals to ARR of I, and then answer equals to maximum of sum comma ARR of I, and then sum less than 0, then sum is equals to 0, which can be represented as sum equals to maximum of sum and 0. Alright, let's see what happens. For the 0th element, sum will add up from 1. Answer is also 1. No update in the answer. Okay. Sum will add to 2 because here it is 2. Let me make the array index elements also here. 3 minus 2, 5. Easy for visualization. Sum will come 2. Sum will add up to 2 from 3. Answer will also change to 3. Okay. 3 plus 3 gives 6. Answer will also change to 6. Okay, no problem. Now 6 minus 2 becomes 4. Answer will only update to 6 only because 6 is greater than 4. Okay. Now 4 will change to 9 and answer will also change to 9. And the loop terminates and the answer here is 9. I say, is that the correct answer? Let me see. Oh yeah, the expected output is also 9. Oh, it has worked. Okay. The time complexity for this would was be O of n because as you saw we are just using one loop that is traversing only up till for that is traversing for n expressions. Okay, no problem. So O of n is the time complexity, and what is the space complexity? Space complexity is O of 1. So it is a overall betterment in the than the brute force approach. All right. Now this algorithm is also known as Kadane's algorithm because the scientist who gave this algorithm. So what does Kadane's algorithm say? Finding maximum sum contiguous subarray. Okay. Let's code out the problem. Because it is given long, so we have to execute long only. Long sum equals to 0 and answer equals to 0. A loop answer is equals to ARR 0, so first element. Sorry for my mistake. Now for end, I will go from 0. I will go up till n. I will increment as each time. The three steps were sum plus equals to ARR of I. If answer is less than sum, then answer equals to sum. And if sum less than 0, then sum equals to 0. At last it was saying that return answer. Let's see if that works. It is working for a custom input on the compile and run. Let's see if it works for submit. Hope it works for submit also. It has been successfully submitted. Thank you for your effort and thank you for watching the video. Please don't forget to like and subscribe. Thank you for watching. Meet you in the next video.